James, where have you been? Well, for one thing, at the start of the year I actually moved house, so I'm in a new space. So things will sound a little bit different. I'm nearer to traffic in this house. I'm thankfully away from trains as I was in the old place, but I'm a little bit nearer to traffic in the new place, so there might be a little bit of background noise. Things might be a little bit different, but I've been continuing with my repairs. I've been very busy with a lot of other jobs this year, but I am continuing with the repairs. When something is worth doing a video on, I will try and do a video on it. I've been doing a couple more boomboxes and bits and pieces. I haven't really done anything that I haven't done before or that I felt was worth covering in a video until now. This Omnichord OM-27 from about 1981 belongs to a viewer. I've actually had this about a couple of months. I think it was about a couple of months he sent it ago, and yeah, I've been so busy. I've been struggling, to be honest, to get through my queue of stuff, but finally got to this, and I've not covered the OM-27 on a video before, so I felt like any kind of documentation I can do on the technicals of these things and anything I can suss out is worth covering and putting on the channel. So yeah, I've got the OM-84, the version that followed it. This is the predecessor. The owner changed the sound chip in this, believing that a fault that it had was down to a bad sound chip. I believe if I open the back and look in the battery compartment, the original sound chip is there in a bit of foil. We were talking back and forth a little bit about what he could do, and as he didn't have an oscilloscope or anything like that, which I suggested it might needed, he said, can I send it to you? That was delayed by my living situation and whatnot, but finally I'm going to get to it. So I'm going to hook this up to a center negative 12 volt supply from my bench power supply, and just set that 12 volts, pop that on, pop on the power. Well, I've got power light, master volume, okay, so rhythms are working. But we seem to have nothing from the strum plate, no chords. Just a pop that resets. Fancy. What's how do you stop this? There we go, yeah, that does the reset. What's really interesting about this, I never realised until I got one in person, the feel of the buttons is so different to the OM-84. The 27 uses mechanical switches, whereas the OM-84 uses a membrane, like a rubber membrane pad. But the feel of them is so different. These are really sort of clicky and positive. The membrane keys on the OM-84 don't feel nearly as good. I never thought that they'd be that different in person, but they are. The stop is a bit hit and miss. You seem to really have to press it. Maybe I've just got really dry hands. So we can definitely hear that popping noise will be the gate transistors opening. It doesn't seem ever so sensitive. I wonder if this is an early one where apparently you needed quite a bit of pressure on the strum plate to make them work. The later ones and subsequent models were a bit more, I believe, a bit more sensitive, so it doesn't seem so sensitive at the bottom. I feel like I can hear it a bit, but definitely no chord or bass, and even that, yeah, even that doesn't seem to want to stop. Okay, so let's have a look. Say I believe the owner said that he'd put a spare chip. Yeah. An anti-static bag and a chip carrier. Lovely. I've actually put a little label on it that says original, So there's our General Instruments, and it is an, if we read through the tape, an AY51317A, and yeah, that's got 49th week in 1981. So this is probably sold in 82, but late 1981 parts. It's a hand-drawn schematic for this one because it's an earlier model. The later ones are definitely drafted, if not computer generated, but I think they're properly drafted, whereas the one for this is a bit of a hand-drawn thing, so it's not the easiest schematic to read. Okay, so that lifts off cleanly. So different to the OM-84, we've got both boards facing down as you take the back up. I think in the OM-84 we've got one facing up and one facing down, didn't we? So the springs keep making that noise. Big hefty power switch there. So yeah, it's sort of interesting that we've had what, 4 separate boards for the whole thing. We don't have the big awkward connector between the two like we do on the 84, which always causes problems, and the 36, I guess. I think, am I right in thinking, and I have to look back at my 84, that the headphone socket at the front and the power input, aren't they on the other side? Aren't they on the back on the 84, and they're on the front on this? It's got that smell of old electronics. It's got that flux smell. Notice a little bodge resistor there. There's a little 10k resistor, I think that is, to the audio jack. That's interesting. I'm not sure if I've got some flux or a bit of corrosion or something here. Just going to check around some of the solder joints. I don't see any evidence of soldering, recent soldering. So I'm wondering if that chip is socketed. You can see sort of pulled around it that these earlier boards were always left with the flux coating on as a sort of makeshift conformal coating, really, to protect them, and it's probably why a lot of the solder, unless it's something mechanical that vibrates or moves, like sometimes switches and such, probably, you know, a good reason that a lot of the solder on these usually lasts a long time. I'm noticing in quite a few places there's solder joints that are bridged, and again I'm going to assume that is factory because they don't look reflowed. It may be that there's a trace underneath them, not sure, but there's happening in a few places. So I probably should go through just a little bit about how the 27 works in comparison to the OM-84 that I worked on before. The OM-84 had a microcontroller that was sending digital data out to a timer chip with 3 outputs. So it could instruct a timer chip to play 3 different frequencies, one from each of its outputs. Each one of those could be tuned to a different chord, or each set of those, should I say, could be tuned to a different chord. So the microprocessor is listening for which button is pressed. When it finds one that's been pressed, it looks through a lookup table to find which frequency should correspond to the note that's been selected, the chord that's been selected, and instructs the timer chip to play those 3 frequencies. Those are then divided down for the strum plate and for the chord section and everything like that, and the bass. The OM-27, because it takes earlier technology, it takes more sort of divide down organ technology in a way. It actually divides the tasks again between 2 chips, but they work in a slightly different way. We've got the M093 here. I've got the data sheets for both chips. This takes a single clock input, so this is a clock circuit. This is our master clock, and this generates, I think this is a 13 tone generator. So this actually generates the 12 notes of an octave plus the top note from this chip. Those waveforms are then fed into the General Instruments chip, the AY51617A, and that chip is connected to the button matrix, and that chip actually selects from which of these inputs to feed to an output to make the chords. So rather than instructing another chip digitally to output the relevant frequencies, this has all the frequencies in it, or given to it on its inputs, and then it selects and outputs the relevant ones. So it's a little bit unusual how it's drawn, I suppose, just to make it a little bit cleaner. These are the extra outputs from this chip. So this is where the not the frequency outputs, sorry, but these are the extra ports on this chip that go into the button matrix. So when one of these is bridged, it will make the selection of which frequencies to choose from its inputs to output for the relevant chord. It's also the reason that this is only limited to 27 chords, whereas the way the OM-84 and the 36 work, by selecting from a logic table in the chip's ROM, they can select a wider range of frequencies, and they can interpret multiple button presses and that sort of thing. So that's what gives that more flexibility in terms of how many chords it can produce. But this one, because it uses a divide down chip and a frequency generator chip like 70s transistor organs, if you like, would use, it's a little bit more limited. So with us having no output from any chords or bass or anything, but we do have drum machines, my question is the M083 working? Because if that's not generating any tones at all, the AY has nothing to work with. That also makes me wonder if the clock is working. I think it would have to be, because the clock feeds the M083 through this transistor here, so it comes off there, goes into pin 2 of the M083, which is the clock input. I just had a cursory glance at the data sheet, I'll show in a second. And the clock circuit, I would think, should also drive somehow the AY, because obviously it's got the tempo control and everything, so it's got to be connected. So I think what I want to do is scope out the clock and scope out the M083 chip and see if we are getting input from clock and output from these 13 pins to drive the AY. I also mentioned as well about the transistor gates. You can hear them popping. I probably didn't explain that very well. I'll do that now. The outputs from the AY chip, when a chord has been selected, they constantly output through the circuit. But what the strum plate does is it opens a gate every time you touch one of the contact pads, and then there's a slow release. It'll be a capacitor circuit that gives it a slow release. It will open quickly and then slowly close. So when there's no audio going into the circuit, you'll still hear that pop as the gate opens. So sometimes when people say, I can hear a popping noise on my Omnichord, but it's not making any sound, that's because, or no tone, that's because there is no tone coming into the circuit, but you will still hear the transistor gates. You'll hear that pop as they open into the amplifier circuit. So what I think I'm going to do is pop these screws out. I note that the owner's marked an X there because the screw doesn't go there, because I think a case screw goes through that. So everywhere else, oh, here as well actually there's an X mark, so that's quite handy. The glare might just cover that up, but there's a little X there to show that a screw doesn't go there, at least not from the inside. So I'm hoping I can carefully flip this board over. May have to remove the ribbon connector. That's easier to do. I can flip it this way. That's easier to do than the OM-84. And it looks like actually just a general purpose ribbon cable at both ends, so it's easier to deal with if it's been broken. Right, so yes, there is some socketing going on here. So here is our AY chip. Here's our M083 chip. They're the correct way around in the sockets, but I note that the direction indicator there, the little notch, is at that side on the big chip and that side on the small chip. So be careful not to put them the wrong way around. It's nice that the buttons stay in place, so this is not too bad to work on at all. So this is the chip that I'm interested in, and this 4069 is our clock circuit, and that's our trimmer for tuning, which interestingly is only accessible from the inside, I believe. Oh no, there's a little slot in the board. So does that mean... No. That's sort of curious. There's a little access point there for the tuning trimmer, but it's not accessible from outside. I'm kind of surprised they didn't put a hole in the case there like they did on the 84 to tune it. There's something a little unusual there. I see a little bit of corrosion at the ground pin. Maybe something or nothing, but it's a bit unusual. Check our continuity. Yeah, it's fine to the pin. It just looks a bit strange. There's a bit of a patch there. Okay, so let's have a look here. Just checking the orientation of the chip again. Make sure I get the numbers wrong, because this is confusing me a little bit. So pin 1 should be VDD, and yep, we got a 12 volt supply. Pin 2 should be a clock, and yeah, that looks like a clock to me. So let's see where my trigger is set. I think my scope set up wrong. It is channel 1, thank you. So we've got about 670 kilohertz clock there. So the clock input is working. And we have ground. Then we should start to see frequencies coming out of this. I'm seeing nothing. So we've got clock input on that M083 chip. That's something on a capacitor because it's syncing. With absolutely no output. As the chip is socketed, of course, it's so easy to remove. I've just folded the board back, just put a bit of paper underneath this just to insulate it. I've put the chip in a breadboard just to make sure that there's no load on the outputs from the AY chips. It's completely disconnected, so it's disconnected from the AY chip at least. So we're taking 12 volts ground and a clock signal over to the breadboard just to test it in this. Unfortunately, this chip is dead. This is the issue. What's unfortunate about it is this is now a long discontinued, very rare, rather expensive chip. There's one in Israel for about 50 quid and there's one in the UK for about 100 quid. Yeah, this was, as I explained, one that was popular in electronic organs, I should have said, not transistor organs, in the 70s as a frequency generator. With it being connected directly to the 12 volts, it does make me wonder if there's been like a bad adapter plugged into the Omnichord or something like that that's cooked that chip. Because although there should be a protection diode in the circuit, I need to have a look through. I believe there should be something. It probably doesn't protect it from overvolt because it's got a 12 volt feed rather than being, for instance, fed from the 5 volt logic supply, so it's not a 5 volt chip. So that appears to be the issue in this case. So I need to speak to the owner, see how he wants to proceed. Just as a bit of an experiment, I decided to try hooking an Arduino up to the what would have been the outputs from the M083 chip. So the Arduino is just running a really simple logic on off program on the digital data pins just to generate square waves basically, and I've just connected that into some of the socket pins where the M083 was. So it's feeding tones into the AY chip, and you can hear, you know, it's sort of working. They're all the same tone, so it's not generating a full chromatic scale, because to try and do that on a, you know, on a microcontroller would not be that easy and probably not that stable, and you wouldn't be able to externally tune it. But so they're all going to sort of do the same key, because it's just outputting one thing. But it is functioning, so we know that the AY chip is working. So at this point, I'm in the middle of the edit of the video when I realise there's an entire piece missing. There was an entire conversation that went between me and the owner that I never actually documented on the video before I moved to the next section. So we're in the middle of the Nutella and crumpets. I want to explain something using the datasheet for the M083. You'll notice it also says M082. Now, as mentioned earlier, when I looked up this M083 chip, as originally fitted to the Omnichord, it's horrendously priced because it's a long discontinued product, and I guess that even says on this, not for new design, and this is dated 1988. So by the late 80s, this chip was obsolete even back then. So to try and find one now, which will probably most commonly be people fixing musical instruments, such as the Omnichord, they're going to be in high demand if they're all failing, and they're obsolete. So the market decides that it can charge 50 to 100 quid for a measly little dip chip. But this M082, this seems quite interesting. How come these are basically exactly the same chip? Well, if I go to actually page 3, I've only printed 1 and 3 to save some paper. We've got this output duty cycle. The M083, as fitted to the Omnichord, is a 50% duty cycle, so it's a full square wave. But the M082, the only difference appears to be that it has a 30% duty cycle. So instead of a balanced square wave, it's a little bit closer to a pulse wave, where it's only on for 30% of the time and it's off for 70% of the frequency. The frequency is exactly the same, it's just that the pulse, the duty, is a little bit shorter. Now, as shown earlier, I had tested this by using an Arduino to generate a basic square wave, and the code was just really simple. Turn all the outputs on, wait an amount of time, turn all the outputs off, wait an amount of time. As those times, those two delay statements were both the same, you get roughly a square wave. So I thought, well, is it possible that this shorter duty cycle can still do the same job in the Omnichord? Can it still drive the AY chip perfectly fine? So I went back into the Arduino code and I adjusted the delay statements for the off time to be longer than the on time, which will give it a 30% duty cycle. Flashed the code, ran it again, and it worked exactly the same. It worked fine. What's so great about these M082 chips? Well, they're a little more easily available, and we managed to get one for £17 instead of 100 quid, which is a little bit better. As I say, I went back and forth with the owner and showed him a couple of quick videos from my phone of the experiments with the Arduino. And my belief that the M082, as it was easily available from an eBay supplier, might work at that lower cost. It's probably worth risking it to try, because I'd feel much more comfortable buying a £17 chip, even though that's a lot of money for a basic dip chip. I'd feel more comfortable spending £17 on it than spending £100 on it for a chip, only to find perhaps it's got another fault, or something else kills that chip. So we went for it. We got the M082 chip, and here's what happened when it arrived. Alright, the M082 chip arrived this week. It's been quite a busy week for me, so I'm only just sort of now getting the time to have a look at this, even though it's quite late at the minute. When I unpackaged the chip, it was all nicely packaged and everything. It was in a little anti-static sponge in an anti-static bag and everything. All seems okay. But the the legs were all quite crooked on it, and it looks to me like the legs have been plated. Just in the interest of checking it's functional, and it's not a Chinese fake or anything, so it didn't come from China, or I didn't order it from China. I'm going to go back to how I had it connected up before, with the 12 volts ground and the clock signal coming into the chip on the breadboard. So this is the old chip that I've just put aside for a moment, and I'm going to go over this on the scope and see if it's functional before I put it in the Omnichord. So I'm going to pop the power back on. You can hear the speaker that's cut in. So there's our clock signal input. With a little bit of ringing on it, but that's probably because of the noise from the breadboard. But let's see on the other pins. Yes, we do see output. So you can see that duty cycle difference is definitely there, but we are getting tones, and also confirms something I was wondering about, that if you look at the deflection there, that says RMS, yeah, 9 to 10 volts. When I put the Arduino in there, of course the Arduino will only do 5 volts on a pulse, and it was a little bit marginal in sort of working properly on the Omnichord, even just as a diagnostic. And I'd actually mentioned to the owner in an email that it's possible that the proper chip should deflect more like 12 volts, because the system of course is running on 12 volts, the input to the chip is 12 volts, and the power, I should say, to the chip is 12 volts, and the power, the VCC, to the General Instruments AY chip is also 12 volts. So I believe that they didn't work necessarily on a kind of 5 volt logic level, but more on a 12 volt level or thereabouts. So it does look like this is functioning, and definitely, yeah, definitely seems good. I did, as I say, want to check that before I put it straight in the instrument, even though of course the instrument's powering it, but all the pins do seem to have a solid output there. So let's pop it in and try it. Alright, power's on. I can definitely hear it going. That sounds good to me. Obviously I need to connect the strum plate, but that sounds like it's functioning. A couple of these buttons I think might be a little bit hit and miss, they might want cleaning. As I said, the strum plate of course is disconnected at the ribbon, so that won't function yet, I can't test that. So I think some of the buttons might want cleaning, but yes, it seems so far the M083 chip does function. Let's just put the power a second. So yeah, if you do have that issue with the dead chip, and I'm not saying this is going to fix every OM-27 ever, you don't know what the faults are necessarily on yours, but if you do have that symptom of a dead M083 chip, and M082, which is currently much cheaper, shh, don't tell anybody, lest they jack the price up, an M082 chip seems that it will substitute. Alright, if you hear noises in the background, my 3D printer's running. Yeah, 3D printing is a thing that I got into this year. That's completely changed my life, it's amazing. But I want to look at the buttons on this. The majority of the buttons, the chord buttons, actually work fine, but for some reason these four seem a little bit marginal. This is something that does come up. I've seen a few people ask how do you clean the buttons and the switches, and I mentioned earlier about the OM-84 and the 36 models having like a rubber membrane, whereas these have a sort of clicky switch. But it actually turns out these do have a little kind of rubber disc inside of the little switch structure, so you can actually take them apart. Now what I've been doing up until now, this is typical when I've got the camera out, is I've been able to just lift them off and it takes off the top of the switch and exposes a little rubber dome. And now that I'm trying it with the camera running, maybe one might do it. No, it's doing the same thing. Now I've got it with the camera running, it's just pulling the actual switch off but leaving the piece in there. So I'm going to see if I can do it. Sometimes it takes a little bit of a wiggle round and then the whole thing will undo. There we go, that's done it. So the little black piece ideally stays in the switch and exposes the little rubber dome, which if you take something like a dental pick and just very gently budge it aside, you can get to the actual contacts. So this little rubber bumper here will have probably carbon coating on it, and then hopefully you can see in there 2 little metal contacts. All I'm going to do is get a cotton bud and some isopropyl alcohol, just soak that, dip off the excess, and then just get the cotton bud in there and just give it a swizz just to clean those contacts, and it will leave a little bit of the alcohol in there. That's fine, it'll evaporate. And then just grab the little rubber bumper bit with some tweezers, try not to lose these, 3D printed tweezers even, and I'm going to try and clean the little surface, the underside of that, with the alcohol as well, just very carefully. Don't go reefing on it, just give it a little bit of a swirl with the cotton bud and the alcohol. Yeah, there's a little bit of black coming off there, which is just excess carbon. So see if we can pop that back in. Then it tips upside down. There we go. So there's still a bit of alcohol in that, so I'm just going to leave that to evaporate. But when it has evaporated, all I've got to do is pop the switch back on, and it's done. So let's see if I can do the others. That one actually took the black cap off, but it fell off. It's one of those things you just sort of have to do by feel. You don't want to be pulling them sideways particularly, you don't want to snap any of the switch parts. And you also, as I say, have to be very careful that you don't lose these little rubber bits, but this way you can get right to the contacts to properly clean them, rather than just praying and spraying with the old spray contact cleaner. So this is what I'm going to do for these 4, and just see if it makes any significant difference. But the easiest way to do the little contact bumper is just put it in the palm of your hand upside down and just very carefully swizzle the cotton bud around it. Alright, we can put these back in. They should just click into place, they don't need much force at all, if you can line them up right, which is easier said than done. There we go. Okay, let's pop on the power. That's better. Yeah. Yeah, they're working fine. I've just put 3 screws back in the board and reconnected the strum plate ribbon cable. Word of warning on this, it's really difficult to get that board connector back in because it's at a slight angle. Unplug it from that one, then plug it into the circuit board one first, and then push it down back into the strum plate one. It's way easier to do than to try and, as I was trying to do, finagle it into that connector so that it's pushed in all the way. Just do it in that order. I should have undone it in that order really. I did give the contacts a clean before I put those in. Trying to get the board back in, as in trying to get all the buttons back through the holes in the top case, is a bit of a job. But I've found if you just sort of hold the board with one hand and then just sort of push the buttons left and right and whatnot until they just kind of pop into place. It's not quite so daunting. I've tested the strum plate, it does work. It's not as sensitive definitely as like my OM-84 for example is, and I did give it a clean with a little bit of alcohol on a cotton bud, and some sort of black did come off. I believe these are gold plated, so if you go rubbing at them again with any kind of abrasive, you're rubbing off the gold, and then you're rubbing away its resistance to oxidation basically. So don't go crazy with them, it's worth just keeping the sort of grease off them. They all work, all the notes work. I'm surprised that there's actually only 12 notes on the OM-27 strum plate, not the 13, because you notice it doesn't have a top dot. You've got the 4 dots at the side which denote the roots of the octaves, but the OM-84 has a top as well, so you get 13 notes. On these you only get 12. I don't think I've seen that noted or documented anywhere. Not any great loss, but it does sound different when you get to the top of the strum plate. So if I pop on the power supply, it does help. All the buttons are now working okay, and the plate does work. It just seems to, it's maybe not too bad now. When I was trying it earlier, it seemed to take a little bit of force to use it, and as I say, I believe these earlier designs were not quite as sensitive as the later one, where it was a sort of, I think it was some sort of membrane, and I don't think the actual top was conductive. I think it was some sort of plastic membrane that was glued in. It wasn't, because you can actually see the exposed traces of the board in this, but yeah, the subsequent ones are quite different, but it is working. But sometimes, yeah, it just takes, maybe my skin's too dry, I don't know. If I lick my thumb, it works really well. So I will clean that before I send it back to the owner. But yeah, if my thumb's a little bit wet, I suppose it's just more conductive, and it works really well, he says. So yeah, the strum plate, all the notes do work. I know it was commented, as I think I spoke about earlier on, the early versions especially, there was a little kind of plectrum, like a conductive rubber plectrum or something that they used to recommend using. So perhaps something like that might help it, but it does function. I think we can call that good. This just needs its final polish up. It's all been buttoned back up, and it'll be going back to its owner, who I hope will enjoy it for years to come. I hope that was of some sort of help or use to anyone who may have a similar issue. If you've got an issue that is different to this with your OM-27, I can take my best guess, but it doesn't mean that I'm going to know everything about them. Sometimes on these videos you get comments like, oh, mine isn't doing this thing. If I haven't covered it in this video, I'm not going to specifically know. If I have covered it in this video, then you might have an idea. So that's sort of where I stand on them really. But the whole point of this is to be able to obviously give them some sort of longevity, and when something comes my way because it needs the oscilloscope, for example, I'm quite happy to try and document that for, you know, future generations to know. So I hope that was of some sort of use and entertainment to someone. There's some more repair stuff hopefully coming pretty soon. I'll keep going with the videos as much as I can, as busy as I am, but for now, thank you very much for watching.